On July 21st, 2023, a single wrong command was sent to a spacecraft 19 light hours from Earth, and for a few days afterward, NASA genuinely did not know if it would ever hear from it again. The antenna on Voyager 2 tilted just 2 degrees off target. 2 degrees does not sound like much until you remember the distance involved. At 19 billion kilometers away, a 2-degree error means the spacecraft's transmitter was no longer pointed at Earth at all. It was pointed at empty space. The signal that had traveled for 46 years through the outer planets, past the edge of the solar wind, into the black silence between stars, simply stopped arriving. For the first time in nearly half a century, humanity's most distant working machine went quiet, and nobody on the ground knew if that silence was temporary or permanent. To understand why that moment mattered so much, you have to understand what Voyager 2 actually is. Launched in August 1977, it was built to survive 5 years and visit 2 planets. It is still operating, still transmitting, still doing science, 48 years later, farther from home than any human-made object except its twin, Voyager 1. It has visited Jupiter, Saturn, Uranus, and Neptune, and remains the only spacecraft in history to fly past the last 2. In 2018, it crossed the heliopause, the boundary where the sun's influence finally gives way to interstellar space, becoming only the second human-made object ever to leave the solar system's protective bubble. Everything about it, its power source, its computers, its transmitter, was designed with 1970s technology, running on a plutonium generator that loses a small percentage of its output every single year. It was never supposed to still be talking to us. And yet, in July 2023, the question was not whether it would eventually go silent from old age. The question was whether a single command, sent from a room on Earth, had accidentally ended the mission early. The command that caused the problem was part of a routine set of instructions meant to adjust the spacecraft's antenna orientation slightly, a normal maintenance procedure. NASA's Deep Space Network has performed countless times across both Voyager probes' decades of operation. This time, the sequence shifted the antenna just enough to break the narrow radio link connecting Voyager 2 to Earth. Because Voyager 2 relies on that same antenna both to receive commands and to transmit data, the mistake did not just interrupt one signal, it potentially cut off the only channel through which engineers could ever fix the problem. If the spacecraft could not hear new instructions correcting its position, and could not send data confirming its status, there was no obvious way back. For a machine older than most of the engineers now responsible for it, a 2-degree mistake looked for a few tense days like the ending nobody had planned for. It helps to picture the actual geometry involved, because 2 degrees undersells how unforgiving deep space communication really is. Voyager 2's antenna is a high-gain dish about the width of a small room, and it has to stay pointed at Earth with extraordinary precision because the signal it broadcasts spreads out and weakens dramatically over distance. A radio beam that is razor narrow when it leaves the spacecraft has expanded to cover an area far larger than Earth's orbit by the time it arrives, which is exactly why even a small pointing error at the source translates into a signal missing the planet entirely at the other end. There's no margin for approximation at this range. The antenna either points at Earth to within a fraction of a degree, or the signal effectively goes nowhere useful at all. That is the part of this story that matters most, and it is easy to miss if you only hear the headline, "Voyager 2 did not go silent," because it broke down. It went silent because of something almost mundane, a targeting error, the kind of small human mistake that happens in any complex operation. The dramatic part is not the failure itself, it is what it revealed about how fragile the entire connection to Voyager 2 has always been. A spacecraft this far away is not controlled the way people imagine. There's no joystick, no live video feed, no instant correction. A command sent from Earth takes over 19 hours just to arrive. Any reply takes another 19 hours to come back, which means that fixing a problem like this is not a real-time conversation. It is closer to writing a letter, addressing it to someone standing at the edge of the known universe and waiting nearly 2 full days to find out if they even received it. So what do you do when the machine you are trying to save cannot hear you, and you cannot afford to simply guess? Engineers at the Jet Propulsion Laboratory faced exactly that problem in the days after the mispointing. Standard commands were useless, since Voyager's antenna was aimed at the wrong patch of sky, and any instruction sent the normal way would sail past Earth entirely, lost in the same empty direction the spacecraft itself was now facing. Instead, the team turned to one of the most powerful transmitters on the planet, the Deep Space Network's largest dish, capable of blasting a signal with far more raw power than a routine command normally requires. NASA engineers nicknamed the attempt an interstellar shout, a deliberately oversized transmission designed to be strong enough that even a spacecraft pointed slightly the wrong way, with an antenna still technically active but no longer aimed correctly, might have a chance of catching a faint edge of it. On August 4th, 2023, that shout worked. Voyager 2 registered the command, adjusted its orientation, and reoriented its antenna back toward Earth. Contact was restored, not through some dramatic rescue mission, since no spacecraft has ever traveled far enough to physically reach Voyager 2, but through pure applied physics. A research team calculating exactly how much signal strength could theoretically punch through 19 billion kilometers of empty space and land on a target the width of a specific slice of the sky. It was, in a very real sense, humanity shouting as loud as it possibly could toward the edge of everything it had ever built, hoping something built decades earlier would still be listening. This was not even Voyager 2's first brush with going dark. In early 2020, the probe lost the ability to communicate with Earth entirely for 11 months, though for a very different reason. The only radio dish on the planet powerful enough to send commands to Voyager 2 sits in Canberra, Australia, and in March of that year, engineers took it offline for a major hardware upgrade. Without that specific dish, there was no way to transmit new instructions to the spacecraft at all, even though Voyager 2 kept sending data back the entire time. For nearly a year, humanity could listen to its most distant machine, but could not talk to it, a strange asymmetry that only this particular spacecraft at this particular distance could produce. When the upgraded dish came back online in October 2020, contact resumed normally, proving the spacecraft had simply kept doing its job, alone, unreachable, for almost a full year, without any instructions from home. Both of these incidents point to the same underlying truth, one that rarely gets discussed outside of mission control. Voyager 2 is not a fragile machine on the verge of collapse. Its actual hardware has proven remarkably resilient across nearly 5 decades. What is fragile is the connection itself, the razor-thin margin required to keep a signal intact across a distance that keeps growing every single day as the spacecraft continues moving outward at roughly 15 kilometers per second. Every year, that connection gets a little harder to maintain, not because Voyager 2 is failing, but because the distance itself is quietly working against it, adding more empty space for every future signal to cross. There is also a strange asymmetry worth noticing in how these two crises unfolded. In 2020, the problem sat entirely on Earth's side, a dish undergoing planned maintenance with Voyager 2 doing nothing wrong at all, faithfully transmitting into the dark the entire time with nobody positioned to answer. In 2023, the problem sat entirely on the spacecraft's side, a targeting error 19 billion kilometers away that no amount of dish maintenance back home could have prevented. 2 different failure points, separated by 3 years, both producing the same outcome: silence. It is a reminder that a connection spanning interstellar distances only has to break in one direction, at one end, for the entire link to collapse, regardless of how well the other end happens to be functioning at the time. Which brings us to the image, or more precisely, the images, plural, because Voyager 2 was never designed to send back just data. Bolted to the side of both Voyager spacecraft is the Golden Record, a gold-plated copper disc containing sounds and images meant to represent Earth to any intelligence that might one day find it. Among the material encoded onto that record are 116 images converted into analog audio signals and etched directly into the disc's grooves, designed so that any civilization capable of building a record player advanced enough to read it could, in theory, reconstruct pictures of our planet. Diagrams of human anatomy, photographs of mountains, oceans, and cities. A nursing mother, a page of mathematical definitions meant to establish a shared starting point with whoever eventually decodes it. It is, quite literally, humanity's attempt to send a picture of itself outward and hope someone, someday, receives it. Voyager 2 also sent back images in the more conventional sense, of course, and its most consequential portraits came during the Neptune flyby of August 1989, the last new world either Voyager spacecraft would ever visit. It photographed Neptune's deep blue atmosphere and its massive dark storm, an anticyclone briefly nicknamed the Great Dark Spot, larger across than the entire Earth. Discovered and then studied through Voyager 2's cameras during the only close pass any spacecraft has ever made of that planet. It also gave humanity its only detailed images of Triton, Neptune's largest moon, revealing active geysers erupting nitrogen gas and dark material across an icy surface far colder than anyone had modeled in advance. After Neptune, Voyager 2 turned its cameras off for good. There would be no more planets left to photograph. Every image after that point would come only from instruments measuring particles, magnetic fields, and plasma, invisible data instead of pictures, because there was nothing left ahead of it to actually see. That is the detail that makes the antenna incident land so differently once you understand it. Voyager 2 has not sent back a new photograph in over 3 decades. What it sends now is telemetry, faint streams of numbers describing the density of the solar wind's leftover particles, the strength of the magnetic field at the true edge of the solar system, and the composition of the thin interstellar medium it now travels through. When the antenna slipped 2 degrees off course in 2023, the world was not at risk of losing a picture. It was at risk of losing the only living sensor, still recording, In real time, what interstellar space actually feels like from the inside. No simulation, no model, no instrument closer to home can replace that. Voyager 2 is one of exactly 2 machines in existence occupying that specific position, and its twin, Voyager 1, is not identical, since the 2 probes crossed into interstellar space along different trajectories and continue to sample a different slice of that same unmapped frontier. That scarcity is also why the mission cannot last forever, and NASA has never pretended otherwise. Both Voyager probes run on radioisotope thermoelectric generators, devices that convert the heat from decaying plutonium into electricity. That decay is steady and unstoppable, and it means the spacecraft loses a small amount of available power every year, regardless of how carefully engineers manage it. To stretch the mission as long as possible, NASA has been switching off individual instruments one at a time over the past several years, turning off a heater here, a specific sensor there, prioritizing whichever instruments still provide the most valuable interstellar data. Engineers currently estimate that Voyager 2 will run out of enough power to operate any scientific instrument at all sometime around 2026, a timeline that has already been extended multiple times through careful power rationing. It could still shift depending on how the generator continues to perform. Even after that point, the spacecraft itself will not stop existing. It will keep moving outward at the same steady speed, carrying its golden record, its cameras that will never take another picture, and its antenna that briefly, for a few days in the summer of 2023, pointed at nothing at all. It will simply go quiet permanently, not from a single mistake this time, but from the same unstoppable countdown that has been running since the moment it launched in 1977, a countdown built into its power source from day one, ticking forward, independent of anything mission control ever does or does not do correctly. There is something worth sitting with in that fact. For a few days in 2023, Voyager 2's silence was accidental, a targeting error potentially fixable with enough signal strength and a well-aimed shout across 19 billion kilometers of dark. The silence coming in the next few years will not be accidental. It will not be fixable with a bigger dish or a smarter command. It will simply be the plutonium finally running out, the same slow physical process that began the moment the spacecraft first left the launch pad, decades before anyone imagined it would still be transmitting from beyond the edge of the solar system. The nearly fatal glitch in 2023 was a preview, an accidental rehearsal for an ending that was always going to arrive eventually regardless of any mistake, human or otherwise. So the next time you see a headline claiming Voyager 2 sent back something that stopped the world, look past the exaggeration and find the real story sitting underneath it, because the real one does not need any embellishment at all. A machine built in the 1970s, running on decaying plutonium, carrying a golden record of human faces and human sounds towards stars it will never reach, briefly went silent because of a 2-degree mistake, and an engineering team on Earth answered that silence with the loudest, deliberate shout the deep space network could produce, aimed at a target 19 billion kilometers away. And it worked. That is not science fiction. That happened. And somewhere out past the edge of the solar system right now, still moving, still listening for the next signal, Voyager 2 is waiting to hear whether we will need to shout again. If this is the first time you have heard about the interstellar shout that saved Voyager 2, drop a comment with which fact surprised you the most, and subscribe for the next investigation into the machines humanity built, and then quietly let travel farther than anyone ever expected them to survive.